Greetings, and welcome to Physics 1. My name is Sean Kemp, and I will be your instructor this semester. I want to go over the first thing that we should always go over at the beginning of the semester, and that of course is the syllabus for the course. My email address is on the first page near the top, and that is probably the best way to get a hold of me during the semester. Obviously, we don't have any actual class meetings, and as a result, it's going to be difficult for me to hold office hours and those kind of normal things. But we all do what we must. In any case, please, if you have any questions or concerns or anything that you'd like to ask me about, please do not hesitate to contact me. I am here at your disposal. I am a resource for you. Now, I know a lot of you may not be used to doing online courses. For a lot of you, this may be your first complete online course. And as such, there are going to be a lot of different changes from the traditional formulation where you go to a lecture, you go to a lab, and you do that several weeks, you take a few exams, and voila. Well, because this is an online course, there are a different set of expectations. Now, I'm going to have all of the lecture videos and things online for you to view, so you can take the course at your own pace. There are advantages to that, of course, because anyone who is able to work at their own pace will definitely learn better. However, it's also easy not to do all of the work. It's incredibly easy to fall behind and not to participate in the manner required or to the degree required to achieve the grade that you probably want for this course. And as a result, the only way really to make an online course work for most of us mere mortals is that you have to take ownership of learning for this course. I cannot be there with you. I cannot look over your shoulder to see whether or not your notes are good. And so you have to take it upon yourself to make sure that you learn the material as necessary. Now, I put every possible scaffolding in place. Obviously, there are lecture videos. I give my lecture notes. There's a textbook. There are all kinds of other resources, and we'll go over each of them in turn. But if you do not use them, you will not succeed. It is that simple. And so what it really boils down to is you taking ownership of your learning for this course, just like every other course that you've ever taken. So if you don't put a lot of effort into this course, you're not going to get a very good grade out of it. Don't dilly-dally. The best thing to do is to take each week's material and do them week by week. There will be homework due every week, and so you really don't have that much of a choice. Obviously, we will take into account all of the holidays and so on. Now, briefly, the official course description for Physics 1 reads something along these lines. Physics 1 is a lecture and lecture and lab is an introduction to the fascinating universe around you from the perspective of conceptual physics. Conceptual physics means that you're really just trying to wrestle with the concepts, the core ideas that make up this body of knowledge that we call physics. Physics, of course, is the study of the physical laws of the universe around us, the physical universe. So, if you care to think of it this way, it's like learning the rules of the game that you're playing every day, this thing we call life or existence, however you want to think of it. In any case, topics include forces, motion, energy, gravity, matter, heat, sound, electricity, and magnetism, which really are one thing, light, radioactivity, and of course, the theory of relativity as described by Albert Einstein. Cats. Yes, I have two cats, and they're probably going to be making guest appearances throughout the semester. I can just about guarantee it. In any case, you may need to know some basic algebra, but that's about it. We're going to go over the very, very basics as required over the first week or so. Any other math concepts that we will need, of course, I will go over with you. But if you can't add 2 and 2, you may find this course a little bit difficult. Now, physics just so happens to be the single most complicated field of study known to humankind. This is not going to be like the other courses that you have taken. It will be difficult. It will require a lot of critical thinking. As a matter of fact, I don't recommend that you try to do too much of the homework alone. It's best done in groups. And I know what kind of difficulty that poses, because right now we can't exactly go to the library and meet up together for a study group. However, we all have things like Zoom and Discord, and as long as you are able to communicate with some of your classmates, you should be able, without much difficulty, to find a good group, one hopefully that works well together and problem solve together. It really helps. In any case, the textbook for this course is Conceptual Physics by Paul Hewitt. It's pretty decent for a simplified or conceptual physics book. There are some sort of glaring inaccuracies and some things that the author hasn't fixed from earlier editions, and I will be going over those and addressing those as the semester goes on. Another good thing to have, of course, would be a calculator. A basic 4-function calculator will probably suffice for the most part, but you will probably need it in order to solve the homework problems. Also, you'll probably want, pencil, eraser, notebook, the basics. Now, because this course is online, of course, you will also need a computer. And you will need internet access. But if you didn't have those things, you wouldn't be watching this video right now, would you? The grade will be split between several main portions. There are laboratory experiments, which you will perform. And unfortunately, it looks like instead of having lab partners or lab groups this semester, you're going to be doing them solo. But that's honestly not the worst thing in the world. And for each laboratory experiment that you perform, you will be writing a laboratory experiment report. We call these labs for short. This will be worth 20% of your grade. 20. That is 1/5 of your grade, or about 2-letter grades on the average. There will be a semester project. And because this is going to be online, you, of course, are not going to want to break quarantine in order to work on building a scale or something along those lines. And as a result, the guidelines are not going to be as they have been in the past. Instead, your semester projects are mostly going to be theoretical. How would you want to go about trying to build a project? Something like a scale that can measure a mass of up to 300 grams, something along those lines. This will also be worth about 20%. Now, in previous iterations of this course, attendance has been a grounds for dismissal. If you do not attend a certain number of lectures, you are not eligible for a grade. However, because the lectures are all online, and it is up to you to watch them, to read the book, to do the homework, whatever works for you with your specific kind of intelligence. If you're familiar with the Harvard theory, that there are, I forget if it's 8 or 12 different kinds of intelligence. There's kinesthetic, where of course you learn better by actually touching something, doing things with your hands, like performing laboratory experiments. That's one of the reasons why that's a major component of this course. There are also visual learners like myself. I need to see something. There are auditory learners, people who learn best when they hear somebody else speak. There are musical learners, of course, people who are just naturally attuned to pitches and things like that. And of course, it's a little difficult to teach physics via music. And so if that's your strong suit, I'm sorry, but you may find this course a little bit out of your element. In any case, the point that I was alluding to is that we do a lot of things in this course in order to try to play to everyone's individual strengths, for one, and for two, because it is not going to be possible to take roll, and there is no way to measure attendance, then you can either watch the videos and read the book or whatever it is you need to do in order to master the material, or not. That is up to you. And so, while in theory, if you don't show up for X number of lectures, you should be dismissed from this course, the same still remains true. If you are falling behind because you're not watching the lectures or reading the book, if you're not doing the homework, if you are not participating in the means necessary, then you probably won't do so well in this course. It's as simple as that. So please take this course, like all of your other courses, seriously. Homework. Oh, sorry, Ninja. My cat. Homework will be worth 1/4 of your total grade, 25%. There will be weekly homework assignments based on the lecture chapters for the week. For example, if we assign chapter 1 on the first week, at the beginning of week 2, the homework for chapter 1 will be due. If we go over chapters 2 and 3 in the second week, by the beginning of the third week, the homework for chapters 2 and 3 will be due, and so on. And of course, I'll try to do my best to account for holidays and so forth. Now, the remainder of 35% of your grade will be based upon 3 exams, 2 of which will be midterm exams, midterms 1 and 2, and the final exam will be worth 15% of your grade. Adding that all up together, that's 100%. Now, it is possible to achieve a grade of above 100%, which, I mean, I can't give you 2 A's or anything along those lines. But if you end up with over 100%, you're definitely going to get an A. That means that there will be some opportunities for extra credit, but we'll go over those one at a time. First things first, let's talk a little bit about labs, or the laboratory experiment reports. These, of course, are going to be completed solo at home, and there will be special versions of these laboratory experiment reports that you can do on your own at home. Now, we just so happen to have a site license for a piece of software here at Evergreen called Logger Pro, which you can download for free. There is a link in the page that this welcome video is on. So please follow that and download it. You will be needing it for your data reduction or to try to make sense of things. It's what we call data reduction, trying to make sense of things, analysis, whatever you want to call it. There will be probably no fewer than 12 but no more than 15 laboratory experiments throughout the semester. Now, if we were going to do this in a lab, I would have to go over a bunch of laboratory safety rules with you. However, because you're going to be doing these at home, I definitely want to go over some lab safety with you because I don't want you burning your house down, okay? There will be some laboratory experiments where you will be asked to contrive a process on your own or try to figure out a way to make something work. Whatever you do, don't light anything on fire, don't shoot anyone, okay? Just be incredibly careful. I will go over the individual difficulties and safety precautions for each of the labs in turn as we go over them. So stay tuned for that. If you look on the second page of the syllabus, you will see that there is an outline for laboratory experiment reports. Also, there is a link to a sample laboratory report on the page that this video is on. Please read it over. It is a good example of what to write and how to write it. The laboratory experiment report is made up of several parts, each of which should be short and concise. Less is more. Each section can more or less essentially be summed up in a few short statements. Now, the reason that we do this is that a lot of you are going to go on to get jobs as engineers or what have you, technicians and that kind of thing. And employers, mostly all over Silicon Valley, but indeed all over the world, are finding that the newest crop of employees, the millennials and the Gen Zs, I'm looking at you, are completely unable, to write a good lab report. So I'm going to be going over that with you. These kinds of things are things that you're going to need to be able to do and write and turn into your boss once you get a decent job that you like. In any case, the analysis and also possibly the conclusion section may need to be made like a paragraph or so, a few sentences, all of which are cohesive in order to get all of your points across. But most of the other sections can be summed up in maybe one or two short statements. You don't want to have any unnecessary words in your lab report. The more time you waste, the more ink and paper you waste, the more you're going to waste everyone's time who has to read the lab report. So don't. As it says, unnecessary text, flowery speech, iambic pentameter, and any unnecessary or extraneous information will result in point deductions. Do not editorialize. Do not discuss unnecessarily. Please stick to the main points and the facts. Also, 110% prohibited from your lab reports are bullet points. If you absolutely have to make a list, something like a procedure that goes in steps, then the list has to be numbered. The big problem with bullet points is generally people do not write correct bullet points and they leave sentence fragments. No employer wants to read sentence fragments, okay? So don't write sentence fragments, write complete sentences. Complete sentences that are intelligible, things that are easy to read, okay? Alright, the first thing that you're going to want to put on your lab report is the title, obviously. So let's say we had an experiment about free fall. You would probably entitle that Free Fall. Also make sure to include your name. If you just so happen to perform a lab report with a partner, and I don't really think there's going to be a lot of room to do that this semester, but we have to roll with the punches as they come. In any case, if you do end up doing a lab report with a partner, lab experiment with a partner, then make sure you indicate the name of not only yourself, but also your lab partner on your lab report. Failure to do so will result in point deductions, correct. Okay, after the title, the first section is the purpose. Sometimes they call that the hypothesis or what have you. Now if we had a lab on, say, free fall, the purpose might be something along the lines of, we are trying to determine, or we tried to determine, the acceleration of free fall gravity near the surface of the Earth. Something like that. How fast gravity makes things fall. There is a section after that called the description, which is a description of the experimental setup, your apparatus, or whatever kind of technology or equipment that you used in order to make your experiment. You will need probably either to draw diagrams or to take photos of at least some part of each one of these experiments. This is not negotiable. You have to have either a picture or a diagram. Usually diagrams are a lot better because they show how something actually works. But these must be included with every single laboratory experiment reports. Diagrams are not optional. Is that clear? Okay. The next section is called the procedure. In the procedure, you will detail how it is that the experiment was performed. I did this, I did this, I did this. Okay? But there is no reason to be overly verbose. If you say something like, I dropped a pen, the pen was red, when it hit the floor it made a clack sound, and then my cat played with it, all of that was totally unnecessary except for I dropped the pen. Please keep it scientific and concise. That is the most important thing. Okay. Probably at several times during the semester you're going to be taking a lot of data. I dropped a pen a total of 5 meters. It took this amount of time the first time I did it. It took this amount of time the next time I did it. It took this amount of time the next time I did it. Those are all data, right? Let's say it took 1.0 seconds, 1.01 seconds, and 1.02 seconds. Those are your 3 trials. And from that you can figure out other things like what the average was and so on, but we'll go over that later. Data belongs in a table, okay? Not in a list, not in a sentence. It belongs in a table. And tables have these things called headers in which you're going to include your units. For example, if we're talking about the distance that we drop the pen, it'd be 5 meters, right? And meter is a unit or a measure of distance. And the time to fall would be the time in something like seconds, right? 1.00, 1.01, and 1.02 seconds. Make sure that those are in there. Please refer to the sample lab report for further information. There's another thing called observations. Sometimes you don't really have the right apparatus in order to make very precise measurements, and instead you can make an observation. Oh, well, I had a piece of paper and I dropped it and it kind of dropped to the ground like a feather, but when I crumpled it up and dropped it, it just kind of fell straight down. Observations. The portion after that is called the analysis. In all likelihood, this is where you're going to take a look at all of your data and try to make sense of what the data means. What does it mean that the pen that I dropped fell from this height, from an initial velocity of 0, ended up with a velocity of such and such at such and such a distance, such and such a time later, and so on. Try to figure out what the acceleration is from there, or what have you. And finally, the last part is the conclusion. Now, the conclusion is generally a synopsis of your findings, and in general what you want to do is compare the conclusion to your purpose, the very beginning. Were you able to succeed? Were you able to figure out what you wanted to figure out? This is where you will also post things like your percent difference or percent error, which is how far you were off from the accepted value or the actual value, how fast things actually fall from gravity or something along those lines, for example. And here you're also going to want to talk about why you had error sources and why they did what they did. For example, let's say you were doing this free fall gravity laboratory, right? And you were trying to figure out how fast things accelerate due to gravity. Now, the accepted value, the value that we've come up with here near the surface of the Earth over many, many years of careful experimentation, is something like 9.81 meters per second squared. Don't worry if you don't know what that means. Okay, it's a number that tells us how much faster something will continue to fall if it keeps falling. Things obviously are going to fall faster and faster the longer you let them fall, right? Stands to reason. In any case, let's say that You performed an experiment, and you came up with a value for the acceleration due to gravity at something like 10.2 meters per second squared instead of 9.81 meters per second squared. Would it be fair to list a source of error as air resistance in that case? Pause the video here and think about it for just one moment. Now, if you said yes, that it would be fair to say that air resistance would give you some kind of error such that your value for the acceleration due to gravity would be greater than the accepted value, you would be very wrong. And the reason for that is very simple. If you're going to list something like friction or air resistance as a source of error, that is only going to slow things down. And let me remind you, the accepted value for the acceleration due to gravity is 9.81 meters per second squared. And if you ended up with a value of 10.2, your value was greater. You said things felt faster. And so it's not possible for friction or air resistance or something along those lines that can only slow things down to be a justifiable source of error. All of your conclusions have to make logical sense. And probably by now you're starting to realize that physics is probably not like anything you ever studied before. It's going to be difficult, but ultimately very rewarding. In any case, the conclusion is in general worth about 3 points out of 10. The analysis is worth generally about 4 points out of 10. And all of the rest, the accounting as I call it, title, purpose, description, procedure, data, and or observations, generally accounts for 3 points in total. Now, a final point, there are several questions in each one of these laboratory experiments, and you must answer all of them. If you do not answer the questions in the laboratory experiment, you will lose points. Okay? So make sure to answer all of the questions in the laboratory experiment. Now, I do not accept late reports, and I do not accept anything, especially lab reports, via email. And as a matter of fact, do not ever try to email me any of your homework, your projects, your laboratory reports, or anything. Alright? That is strictly forbidden. If you have to submit one of these things, there is a place for you to do it on the assignment page in Canvas. That is the proper place to do it. Okay? Thank you. Now, let's talk a little bit about the semester project. The semester project is generally a collaborative effort. You're going to be in a team of probably 3 or 4 scientists, and your job is to try to make a scale that will accurately measure a mass no bigger than about your fist and no more than 300 grams. Okay? A little more than half a pound. Now, because you're not going to be able to actually build it and work together and perform the experiment in class, because we're not going to be in class together, the project is never actually going to get all the way finished. Instead, what you're going to do over the course of the semester is plan out, how you would build this project. How you would test it out and what kind of error you think you would expect from it. Okay? There are several limitations, of course. You cannot use an actual scale, something that you can buy for retail. You cannot buy a pre-made kit. You cannot buy a scale that can be purchased in a store, those kinds of things. The materials that you can use to make this project Can be just about anything you can find around the house. You can use chunks of wood, rulers, springs, rubber bands, ropes, whatever, rod wires, anything that actually works. You are not allowed to use, however, liquids or powders. End of story. Now, in theory, the homemade scale has to fit through the doors of the classroom. And obviously we're not going to be in the classroom, but you still have to make the scale not too big. Let's say no more than 3 feet wide and no more than 2 feet front to back. That way it could fit in through the door. Let's say also no more than 3 feet high. Okay? So no more than 3 feet from left to right, no more from 2 feet, no more than 2 feet front to back, and no more than 3 feet top to bottom. That's it. You cannot have any electronics in this device. Period. That's cheating. The point of this project is to try to make a scale that is completely analog and uses the principles that you learn in this course in order to try to determine the mass that you would be given. You should be able to fit an object about the size of your palm up to about 300 grams. In theory, you would have about 10 minutes in order to make the calculation, the measurement, and try to figure out how massive the object that I give you is. Because in the past, what we did is teams would build their scales, and on project presentation day, I would give you a mystery object, you would put it in your scale and try to figure out how massive it was. Now we're going to do a sort of mock-up instead this time. But you still have to build your, or plan to build your scale such that you can measure a device or an object about the size of your palm, your fist, and up to 300 grams. You can use a calculator, however, if you're using like a balance beam or something along those lines. Now, let me caution you about the next part. Do not spend a lot of money on this, alright? The last thing that you want to do is go way out of your way to spend a bunch of money on a project, especially if you don't have a clear plan. This is why I say try to keep the cost to $0, okay? Do not spend a lot of money on this project. Use things that you can find around the house. You can start thinking about designs now. I would start by trying to find a semester project group. And probably, as you will see, by the second week or so, you will have found your group. Also, before you actually try to go forward with anything, you have to get my approval on your scale design. Now generally, what we've done in the past is that there would be an actual project that we would grade, that we would try to use to measure things, and that would determine your grade. Using the system under the heading scoring on the third page of the syllabus under semester project. Let me just read it really briefly. You start out with 50 points, and if you're off by 10 grams or more, you fail. The farther that you are off from the scale, or from the actual value, the more points you will lose. Each group's measured deviation of mass from the actual mass will be multiplied by 5, the number of grams that is multiplied by 5 and subtracted from your 50 points. Now, because we're not actually going to do this, instead, by project day, you have to have your design ready to go, and you will turn that in. Okay? Everyone will write an individual version of the plans. There will be no plagiarism, and that goes for lab reports and everything else as well. You have to write your own and in your own words. Okay? We're going to use the format for laboratory experiment reports: title, purpose, description, procedure, data and or observations, analysis, and finally conclusions. And you will submit those by project day on the semester project assignment page. Now, there is another page, the presentation page, excuse me. There is another page called the report, and that is for your progress report. Throughout the semester, you have to document how the fabrication of the design and everything came together. This, of course, is also worth 50 points. You have to date these entries as they come. If you have fewer than 5 entries, you will receive 0 points. You must submit your own progress report, and that will be submitted on the report page for the semester project. This, of course, will also be due on project day, no later than. Okay, let's talk a little bit about homework. You're going to try to solve a bunch of problems in your homework, right? The art of studying physics is making sense of real-world problems. Whether or not we realize it, we solve physics problems every day. How long is it going to take me to get to the store? How much gas do I need to put in my tank? These are all physics problems because they are problems in our physical world. You will be learning an entire new outlook on problem solving, and hopefully it will help you in every aspect of your life. You'd be surprised. People use it everywhere. Now, in order to solve physics problems, you're going to need to think critically, just like in real life, in the real world. I very strongly suggest that when you're working on your physics homework problems, you work in a group. Get Zoom, get Discord, something along those lines, so you can bounce ideas off each other. It helps. Once you understand part, even if it's just part of a problem, once you understand that part, if anyone else in your homework group doesn't understand that, do your best to try to explain it to them. Explaining even small parts of problems to people that are in your homework group will help everyone in the group learn, including you. They say the best learning experience is to teach. Now, we will spend some time in the lecture going over some sample problems and so on. And of course, if you have questions about problems in particular, you can always email me. However, I'm not going to do your homework for you, so don't ask me tons of problems about your homework. You can ask me 1 or 2 maybe, but like I said, I'm not going to do your homework for you. So don't try to get me to do all of the homework problems from your homework set, okay? That being said, if you get stuck on a problem, you can always email me, etc. Also, the online tutoring, I believe, is free and easy to sign up for. And so if you need some free tutoring, and we can't figure out how to make office hours work, of course, you can always get the free online tutoring on Canvas. You have to sign up for it. I believe it's a 0-unit course. Now let me repeat, I do not, for any reason whatsoever, accept homework submissions via email. All the homework is going to be done online at masteringphysics.com. If you don't take the time and put the effort into solving the physics problems yourself, you will not do well on the exams, and therefore you will not do well in this course. Okay? Now, on the first day of class, you will have until midnight to do the following. You want to go to masteringphysics.com, locate Register Now, click Student, click OK, Register Now, and there will be a little box that says enter your course ID. When you do so, you're going to use the course ID that is in the syllabus under the heading homework. It'll be something very easy for you to find. Okay, you just take that, you can basically just copy paste it, click continue. If you don't already have an account with Pearson, who runs Mastering Physics, you will have to create one. Now, if you bought a brand new textbook, one of the new edition of Hewitt's Conceptual Physics, I believe it comes with a homework code for free. If not, you will have to sign up for the homework code. I believe that's at a small cost to you. It's less, of course, than the textbook. Textbook, I think, is actually kind of expensive. So, you know what, we'll come back to the textbook later. So you want to sign into the course, give your EVC student number to enroll, and you can of course see the online homework schedule both there and here at the back of the syllabus. Your first assignment is to go through and familiarize yourself with the homework platform in something that's called the Introduction to Mastering Physics. You will need to complete this before midnight tonight. There's also something called the Physics Primer, and that's just a check to make sure that you can do the basic math required for this course. If you cannot handle either of those, I very strongly suggest that you think about registering for another course this semester and take physics when you can give it the attention that the course is going to require. Most chapter homework sets will be accessible 1 week before they are due, so you have essentially a week to do each homework set. I will only see your homework grade after it is completed. Do not wait until the last moments to start your homework, as they have an absolute deadline to them. You can see them up until the last day of class, but they do not count as they do not count for points, after the posted due date. Now, the homework, you know what, we'll go over that later. Let's talk a little bit about the midterm exams. The midterm exams will be done online on Canvas. Since you're going to be using your computer to take these, we will be using an online proctoring service, a secure proctor service. That will allow us to make sure that everyone gets the secure platform they need. Now, the exams themselves will be about 2-hour exams or so, and like I said, they will be online, requiring the online secure proctor. On this proctor there will be a built-in calculator applet, and so you can just sort of use that to solve the problems, as well as there's like a little chalkboard dealy so you can kind of scribble out what you need to do. There will be several different types of problems on these exams. There will be some true-false problems at the very beginning, followed by some multiple choice questions. Now, obviously, if you have a multiple choice problem, you want to try to make sure that you employ the right strategy for getting that problem correct. Obviously, true-false, you're like 50-50 even if you guess. If you have a multiple choice problem, let's say that there are 4 possible answers. If you just guess willy-nilly, you have a 1 in 4 or 25% chance of getting it right. You don't lose points for getting it wrong. This is not the SAT. You either get the points for the problem or you don't. That's it. So it is in your best interest, if you don't know the answer, to guess. Now, like I said, if there are 4 possible answers, and if you can eliminate one of them, then your odds have just gone up to 33% of getting it right. If you can eliminate 2, you got a 50-50 shot. And that's much better. Okay, so try to eliminate the incorrect answers. If there are, if you're trying to put together the answer for a different kind of problem, like the short answer or the math problems, then you're going to have to use a different approach. If you have to actually solve a problem out, then those problems you're going to have to scribble it out, write it out, draw your solution, draw a diagram, whatever you need to do, and then you're going to need to upload that to Canvas. I would suggest that you familiarize yourself with the program Paint or something along those lines, long before there is a midterm exam. Try solving some problems, some homework problems or something along those lines, using Paint to try to write out and solve your problem. There is a foolproof problem-solving method for physics, and we'll be going over that in the coming weeks. Now, if you come across one of these problems on one of your exams, there will be a spot for you to upload your answer. Don't upload things like Word docs or things like that, okay? You want to be able to put diagrams and, you know, kind of draw in order to try to make a sensical answer. So familiarize yourself with something like Paint. Do yourself a favor, okay? If you don't get all the way through the problem and don't get the right answer at the very end, that doesn't mean that you won't get some credit for trying to solve that problem. You will not get through, no one gets through an education in physics without partial credit. That's just crazy talk. Okay? So, when you try to solve your physics problems, write out each possible step, highlight all of the theory that you can. Don't obviously throw in anything that's not part of the problem. But write it all out step by step. Okay? That way, I can give you partial credit even if you get the problem wrong. Long story short, show your work. You have to show your work, otherwise you cannot get partial credit. Okay? It's much more important to understand the thought process than to memorize facts or figures. You're going to want to put useful information such as equations with constants and constants with the appropriate units on your worked out problems. Okay? You will get a formula sheet for these exams. I will give it to you. You can print it out, and when you take the exam, you have to show the piece of paper front and back to the camera and leave it in plain view of the camera throughout the exam. Okay? There will be no scratch paper. There will be no books. There will be no other computers. You're not allowed to use your phone. You are not allowed to call people. You're not allowed to talk to people. I'm sorry, I understand this is like 1984. Big Brother is watching you, but it's better that we all work honestly and try to come up with these answers honestly, okay? And that's why we use the Secure Proctor for these exams. So, to summarize, there will be no phones, no books, no computers, other than the one that you're going to be taking the exam on. There is no communication. You cannot use Discord. You cannot send messenger chats to people, okay? The Secure Proctor will look at your screen as well as your camera the entire time. If you don't have a laptop or a computer, there is a program that will allow you to borrow one from Evergreen. That, of course, will require that you need to go to campus at some point, but I mean, if you go once, they're going to give you a laptop to use for the semester. That's pretty good. Just make sure, of course, that you wear mask and gloves. Glasses, of course, help. Your eye is also actually a mucous membrane, and so if we're worried about COVID, it's best to wear safety goggles, snowboarding goggles, something along those lines, just so that any aerosolized COVID doesn't actually get into the mucous membrane in your eye. But try not to break quarantine if at all humanly possible, okay? Stay safe, please. Now, homework and exam problems will not be identical, but they will be probably similar. And so you can use the same process that you used, to solve a bunch of your homework problems to solve a bunch of the exam problems. Okay? The final exam will be on the last day of the class. You can see that on the class schedule at the end. Now, I'm supposed to go over with you the general policies on withdrawals and drops and academic dishonesty. Obviously, disruptive behavior probably won't be much of an issue. However, you are not allowed to turn in the exact same thing as anyone else. That is called plagiarism. You are not allowed to use cheat sheets, let others copy your work, discuss things during exams, and so on. I have never had to send anyone to academic honesty, so please don't make me make you the first, alright? That is a breach of trust in between you and I will not look kindly upon that. I will not be happy about that, okay? Use common sense and decency. We're all here together to try to learn. Also, as an ancillary or an added resource, there is a link under the ancillaries heading to a Dropbox page where you can find the PowerPoint presentations, if you're the kind of person who learns better from PowerPoint, for each chapter in this book, as well as what we call clicker questions, or just sort of basic questions you can quiz yourself with in order to see what your overall understanding is like. Take a minute to look at the calendar. You can see there are 3 columns in the calendar table. The first is week of lecture, so there is going to be a number of lecture videos that are posted each week, and those of course will correspond to chapters of the book. Also, it'll say what chapters those are, as well as hopefully the laboratory experiment that we have for that week. That of course means, yes, there will be, hopefully, a laboratory experiment just about every week. Almost. Now we may have to make some exceptions for the exams, for the project and so on, but we'll figure that out as we go. And it's for that reason that the last column is labeled tentative lab schedule. We may have to change things as they go, but hopefully we won't. You can see how many weeks there are and when the exams are. Those are in bold print. Okay? Also, project day is in the early half of our last week. The final exam will be on the last day of class. Finally, we have extra credit, for which I will assign you several opportunities for extra credit. Generally, I have an open invitation for community service. If you want to do community service, you can get extra credit, but as long as there's a COVID quarantine, it's probably not a good idea for you to be leaving the house, so maybe don't do that. There will be other opportunities for extra credit, of course, throughout the semester. If you have any suggestions for a good extra credit assignment, I am all ears. But there are going to be restrictions, of course. Obviously, if it's something that's going to be abusable, I'm just not going to allow it, and that's going to be the end of it. This is extra credit, not something that you are owed. Is that clear? Now let me give you your first opportunity for extra credit. If you are able to tell me when the International Space Station is going to fly over San Jose in a place where it would be visible from Evergreen Valley College, the International Space Station that is, as it flies over San Jose. During the time that this course is listed in the schedule of classes, then you will receive some extra credit. That's my first challenge to you. Only the first person will get extra credit. The first person who points this out will get extra credit. Now, let me explain a couple other things to you. The right time to ask for extra credit is not at the end of the semester after you've been neglecting this course and your grade in it for the entirety of the semester. And it is for that reason that extra credit, because it is not a replacement for the elements of participation in this course, those are things like homework and exams, laboratory experiments, and so forth. Because extra credit is not a replacement for participation in this course, extra credit can never bump you from an F to a D. However, if you are at a high B and you're really, really close to getting an A, and you do a little bit of extra credit, that might bump you over into the A category. Okay? Now, generally, I may offer like a research assignment or something like that if I deem it necessary, but generally the only reason for that is if you get run over by a bus and you're in a coma for 2 months or whatever, and you come out and you're just like a magical physics savant and you understand everything about everything. And no one ever does that, ever, and so it's probably not going to be really necessary for us. Okay? For us normal human beings, we don't go into comas and come out with perfect understandings of physics. That's not how it works. It doesn't usually come without a lot of hard work. Okay? Poor exam scores are not a reason to get extra credit. Not coming to class or not actively participating, not doing your labs, not doing your homework are not reasons for you to get extra credit. Okay? The student learning outcomes, I'm required to go over these with you. You have to know the difference between linear and rotational motion. And of course that's the difference between something moving in a straight line and something rotating. And also wave motions. And I'm sure you've all seen water at the beach, right? You've all played with a slinky, so you have some idea what wave motions are. Don't worry, if none of these student learning objectives make a whole lot of sense to you right now, don't worry, okay? In the future, you will understand these better, okay? Explain Newton's laws of motion, of which there are 3. We'll go over those in the upcoming weeks, of course. You have to be able to formulate the principles of conservation of momentum and conservation of energy. And you probably don't even know what those are right now, so don't worry about it. Conservation just means that it is not lost. That the total amount of energy, for example, if we want to say energy is conserved, the total amount of energy in the universe basically stays the same. It can go in between systems, it can change forms, but essentially the total amount of energy in the universe remains constant or conserved. You have to be able to describe the law of universal gravitation, or Newton's law of universal gravitation, and the motion of satellites, things like the moon around the Earth. You have to relate the properties of matter to their physical states, namely, of course, solid, liquid, gas or vapor, and plasma. You should be able to describe temperature, heat transfer, and the change of phases. Things like if you apply heat to an ice cube, it's probably going to melt, right? Apply descriptively the laws of thermodynamics. We'll talk a little bit more about thermodynamics, or the study of heat, later on in the semester. Explain the properties of waves, including sound and light waves. Apply the basic principles of electrostatics, electric current, electromagnetism, and so forth to everyday phenomena, things like turning on a light switch or turning on a flashlight, playing with your phone, etc. Explain the reflection and refraction of light. Now you probably know what reflection is. You can probably see a little bit of the reflection in my glasses here. You've all looked in mirrors. Refraction is how light bends. Like if you look into the water, right? If you look into some water, things look like the water isn't necessarily as deep as it actually is. That's because the light is bending as it goes through the water, which is much more optically dense than the air is. You should be able to discuss a little bit about the origin of radioactivity, radioactive isotope dating, and half-life. We'll talk a little bit more about that later on in the semester. And you should always be able to implement the scientific method. And we'll talk more about that over the course of the semester as well. Now, on the very last page of the syllabus is a contract. And I'm leaving this here in the syllabus for a very specific reason. You'll notice that there is a spot for a signature and a name and all that. And believe it or not, this is the one contract in your entire life that you have signed, whether or not you've actually written your name on it. The syllabus of a course is a legally binding contract, and by participating in the course, you are agreeing to all of the guidelines therein. So, everything in this syllabus you have to know you are responsible for, okay? You have to know everything in this syllabus. From this point forward, you're responsible for all of its contents. Whether or not you like it, whether or not you signed it, you have signed this contract. Okay? So everything in this contract is now yours. Make sure you know it. Of course, it'll be accessible via Canvas, via the syllabus link on the left, as long as you're in the course, of course. And it should be readily accessible to you throughout the semester. So I don't think that will be an issue. But I want you to know that this is the one contract that you have signed, whether or not you signed it. And anytime you ever sign a contract in this life, you should definitely read every word of it. So, before going on any further, I would suggest that you go back and look over the contents of this syllabus very carefully. Okay? I hope you've enjoyed this video about your syllabus and all of the information in it. We'll begin shortly hereafter with Chapter 1.